The next class that we're gonna discuss is a driver class, right? So we start with a driver. The first thing that we require in a driver class is an access to an interface, right? So we start with a virtual. The interface is declared with the name wb_if and the instance name will be VIF. We also required the transaction which will serve as a data container, okay, where we will be receiving a data from a generator, right? And one event that will convey that driver completed its task of triggering an interface, right? So we declared a mailbox that will receive the transaction, okay, from a generator. We again provide the same name, which is mbxgd, right? Then we add a constructor to the driver which will expect an argument as an mailbox, and then we'll just be specifying that the mailbox that we have declared in a driver and the argument both are same, right? The simplest task that we have in a driver is to perform a reset of a system, right? So we start with the task, a reset, and we know that the type of reset that we have assumed for our system is an active high reset, right? So we first access the reset pin, so vif.reset, and then we make it high, right? While rest of the signals will be initialized to a 0, right? So WE, which is mode control pin, is initialized to a default value of 0, address is 0, write data is 0, and strobe is also 0, right? So we keep our system resetted for 10 clock tick, okay, and then we remove a reset, right? So we do not immediately start an normal operation, but we wait for 5 clock tick, then we send the message as reset done, and then we'll start our normal transaction, right? So this is what we have in an reset task, right? So we already have discussed that we have 3 modes of operation in our system, right? So we assume that there will be 3 modes of operation that we're gonna verify in this specific code. First one is a write mode, then we have a read mode and the random mode, right? So we have design a task for each mode, right? So we have a task write for a write mode, then we have a task read for a read mode, and then we have an independent task for a random mode, right? So we first start with the write mode. Now if you remember, for a write mode, right, so how we proceed is on the positive edge of a clock we make strobe high, and the mode control pin, that is WE, should also be high, right? At the same time we need to apply address and data, okay, and then we wait for an acknowledgement, and as soon as we receive an acknowledgement, our transaction complete, right? So we proceed like this. We make reset 0, right? So reset should be 0 during a normal operation. Mode control pin should be 1. This is what we did over here. Strobe should also be high. And when we make strobe high, okay, so at the same time, WE, address, and W data must all have a correct value which we want to send to a DUT, right? So we make WE high because this is a write mode. Both address and data that we received from a generator, we are sending it to address and W data pin of our DUT, right? Now we know that we need to wait till we receive an acknowledgement, and as soon as we receive an acknowledgement, we complete a transfer, right? So we wait for the positive edge of an acknowledgement, and we do not immediately start a next transaction. Instead, we wait for 1 more clock tick, right? And then we trigger DRV next, right? So this will convey the message to a generator that we completed the process of triggering an interface, right? So this is an extra clock tick that we have added before we start a next transaction, right? And once we add certain pattern in any of a task, we need to follow the same pattern, right? So if you go to a read task, now for a read task, okay, we need to again make strobe high, WE should be 0, and then we need to add an address at the same time when we make strobe high, right? This is what we're going to do in a read task. So we wait for a positive edge of a clock, then we make reset 0, okay, WE should be 0 for a read mode, okay, then strobe should be 1, and we also need to provide an address, and address will be coming from the generator class, right? Again, we wait for a positive edge of an acknowledgement. We wait for 1 clock tick before we trigger the event DRV next, right? So this is what we have in an read mode, and this is exactly following the same pattern that we have in an write task also, right? The next one that we have is a random. Now only difference between read and write and random is here we won't be forcefully adding a value for WE. Instead, whatever value that generators send us for WE, we will be sending that to the DUT, right? So we start with the task random, we wait for a positive edge of a clock, we make reset 0, WA should be equals to the value that we receive from a generator, right? So this is the difference that we have between random mode and the specific read or write mode, right? Then we also take the value of a strobe which is generated by the generator and applying it to a DUT. So we are least concerned whether we generate a valid transaction or not, right? We know that for a valid transaction, strobe should be 1. But when we consider a pseudo random number generator generating a value for a strobe, here we cannot be sure that always we get a valid transaction, right? So it purely depends on the value that pseudo random number generator generate for us, right? So whatever value that we received for a generator, we send it to a strobe. Similarly, we apply an address. Now we have two possibilities, right? So when WE is 1, okay, in that case we need to send the data also, because this is write mode, and in a case of a read we do not need to send anything, right? So if write is 1, we basically send the data that we receive from a generator, else we will be sending the default value to a W data, right? Then we wait for a 2 positive edge of a VIF clock, right? Now here we cannot add a wait VIF dot acknowledgement. The primary reason being, okay, so if we do not have a valid strobe value, remember, if we do not have a valid strobe value, then we cannot get an acknowledgement, right? So we will receive acknowledgement only when we have a strobe high. Okay, so if you count the number of clock tick, right, so here you could see this is a positive edge of a clock. Okay, so this will be this positive edge of a clock. Now here, instead of strobe equals to 1, we will be adding a random value, right? Then we receive an acknowledgement over here. So in the next clock tick, we will be receiving an acknowledgement, right? So this is a wait statement that we're gonna add. And if we need to follow the pattern that we have used in a read and write mode, so we have added one more extra clock tick, okay, before we start a next transaction. So you could see for an acknowledgement we required one extra clock tick. Okay, so this is where we start our transaction. We required one clock tick delay, and then to match the delay that we have added in an read and write task, we need to add one more clock tick, right? And for that reason we have added the wait of 2 clock tick, right? So one clock tick which is extra that we have added in each of this tasks, that is write, read as well as random, and one clock tick which is required to complete the transfer, right? So here we start our transfer, and in the next clock tick we receive an acknowledgement that basically completes our transfer, right? Now you could clearly guess why we have added repeat 2, because we need to add one clock tick. Okay, so that is the point where we receive an acknowledgement if we have a valid strobe value, and then one extra clock tick which we have added in all the tasks, right? Then we trigger DRP next, right? So this complete all the tasks. Now we proceed to the main task of a driver, right? The first thing that we add over here is a forever begin, okay, and then end. Then we receive a transaction from a generator, and if op mode is 0, that specifies that we wish to perform a write mode, so we'll just be calling a write task. If op mode is 1, in that case we need to call a read task, and if op mode is 2, in that case we call a random task, right? This is what we have in the main task of a drive, and then we add an end class, right? So we already have trigger a DRV next in write, read and random task itself, so we do not need to add an triggering of an event after this end, right?